Imagine pressing the accelerator of a spaceship, and no matter how hard you push, you never reach the speed of light. Not because your engine is weak, but because the universe refuses to let you. Light speed isn't just fast, it's a boundary built into reality itself. Break it and time falls apart because comes after effect and the universe stops making sense. Richard Feynman once hinted at a shocking truth: the speed of light is not about light at all. It's about how space and time are constructed. And once you understand why, you'll never look at reality the same way again. When we first hear that the speed of light is the ultimate limit of the universe, it's easy to think the story is simply about light being extraordinarily fast. But the deeper truth is far more surprising. The speed of light is not just a property of light itself. It is a fundamental feature of how the universe is constructed. Light merely reveals this rule to us. Long before physicists understood atoms or galaxies in detail, they assumed that space and time were fixed, absolute backgrounds where events unfolded. Speeds could always add, clocks ticked the same everywhere, and rulers measured the same lengths no matter how they moved. Light shattered that comfortable picture. Experiments showed that no matter how fast an observer moved, light always traveled at exactly the same speed. This wasn't a small correction or an experimental error. It was a direct contradiction of everyday intuition. Once this fact was accepted, it became clear that something much deeper than optics was at work. The universe was telling us that space and time themselves must change in order to keep this speed constant. The shocking realization is that the speed of light acts like a structural constant of reality, similar to how the number of dimensions or the existence of gravity defines the universe we live in. It sets the scale at which space and time are connected. Instead of being separate things, space and time are woven together into a single fabric, and the speed of light is the thread that binds them. It tells us how much distance is equivalent to how much time. When something moves through space, it is also moving through time, and the speed of light governs how that motion is divided between the two. This means that light is not special because it is made of photons. It is special because it exposes the geometry of space-time itself. Even if light did not exist, there would still be a maximum speed built into the universe. Light just happens to travel at that speed because it has no mass. This idea completely changes how we think about motion. In everyday life, speeds add up neatly. If you walk inside a moving bus, your speed relative to the road is just the speed of the bus plus your walking speed. But this rule quietly assumes that time flows the same for everyone and that distances are fixed. Once the universe insists on a fixed maximum speed, those assumptions can no longer hold. Instead of allowing speeds to add freely, nature adjusts time and space themselves. Clocks tick at different rates depending on motion, and lengths change depending on how fast something moves. These effects are not illusions or measurement errors. They are direct consequences of the speed of light being a fundamental limit. The universe reshapes its own measurements to preserve that limit. What makes this especially profound is that the speed of light is the same for all observers regardless of their state of motion. There is no preferred frame of reference, no absolute rest, no cosmic background that defines true motion. Everyone, no matter how fast they are moving, measures light to travel at the same speed. This forces reality to be democratic. No observer gets special treatment. Space and time adjust so that the laws of physics look the same to everyone. The speed of light is the enforcer of this fairness. It ensures that the universe has a consistent set of rules that apply everywhere and everyone. Another way to see this is to think about cause and effect. The speed of light defines how quickly information can travel. It sets the maximum rate at which one event can influence another. If this speed were different for different observers, or if it could be exceeded, the order of cause and effect would become ambiguous. What one observer sees as a cause, another might see as an effect. The universe avoids this chaos by embedding the speed of light directly into the structure of space-time. It becomes the boundary that separates what can influence what and in what order. In this sense, the speed of light is not just a speed, it is a rule that protects logical consistency across the universe. This is why calling the speed of light a limit can be misleading if we imagine it as a barrier we simply haven't yet learned how to break. It is not like the sound barrier, which was once thought impossible to cross but eventually was. The speed of light is different because it is not about engineering or materials. It is about geometry. You cannot engineer your way out of the shape of space-time any more than you can build a machine that makes triangles have four sides. The speed of light is woven into the definition of distance and duration themselves. What makes this idea beautiful is its simplicity. From one strange but well-tested fact that the speed of light is the same for everyone, an entire worldview unfolds. Time becomes flexible, space becomes relative, and motion takes on a new meaning. Light is not just illuminating the universe, it is revealing the deep rules that govern it. The ultimate lesson is that the speed of light is not an arbitrary number or a quirk of light waves. It is the signature of how reality is built, a constant that tells us what kind of universe we live in. When the universe insists that the speed of light must be the same for everyone, something extraordinary has to give, because our everyday expectations about motion simply cannot survive that rule. In ordinary life, we assume that time flows at the same rate everywhere and that rulers always measure the same lengths no matter how they move. These assumptions work perfectly well at low speeds, which is why they feel so natural and obvious. But once objects begin to move at speeds approaching that of light, these assumptions quietly break down. To preserve the constant speed of light, nature does not slow light down or speed it up depending on the observer. Instead, it changes the very things we use to measure speed in the first place, time and space themselves. This adjustment is not a trick or a mathematical illusion. It is a real physical effect that has been confirmed countless times by experiments and modern technology. Consider time first. If two identical clocks are synchronized and then one is set in motion at a very high speed while the other remains at rest, they will no longer agree when they are brought back together. The moving clock will have ticked more slowly. This effect, known as time dilation, is not due to mechanical failure or imperfections in the clock. It happens to atomic clocks, biological processes, and even unstable particles that decay more slowly when moving fast. Time itself flows differently depending on motion. This sounds like science fiction, but it is an unavoidable consequence of keeping the speed of light constant. If time did not slow down for moving objects, different observers would measure different speeds of light, violating the most basic rule the universe seems to enforce. Now consider space. Length contraction is the equally strange but equally real partner of time dilation. Objects moving at high speeds become shorter in the direction of their motion when measured by a stationary observer. This does not mean the object feels crushed or distorted from its own point of view. To someone traveling with it, everything appears normal. The contraction only appears when measurements are compared between observers in relative motion. Once again, this effect exists to protect the constancy of the speed of light. If lengths did not shrink, distances would remain the same while time slowed down, and the speed of light would no longer come out equal for everyone. Space adjusts itself just as time does. What makes these effects so hard to accept is that they challenge the idea of a single, universal now. Events that appear simultaneous to one observer may not be simultaneous to another who is moving relative to the first. This relativity of simultaneity is often overlooked, but it is essential. Without it, the adjustments of time and space would not work consistently. The universe does not provide a master clock ticking in the background for everyone to agree on. Instead, each observer carries their own time, and the relationships between these times are governed by the speed of light. This may feel unsettling, but it is precisely what keeps the laws of physics consistent across different perspectives. These changes in time and space are not symmetrical accidents, they are tightly linked. You cannot have time dilation without length contraction, and you cannot have either without the relativity of simultaneity. Together, they form a self-consistent system that ensures one thing above all else: no matter how fast you move, you will always measure light to travel at the same speed. The universe enforces this rule with absolute discipline. Every adjustment in time is balanced by an adjustment in space, and every observer gets a version of reality that fits the same underlying laws. At first, this may sound like a cosmic conspiracy designed to confuse us, but it is actually an elegant solution to a deep problem. The problem is how to make physical laws the same for everyone when there is a maximum speed. The solution is to abandon the idea that space and time are fixed and separate. Instead, they become flexible and interconnected. Motion through space affects motion through time and vice versa. This trade-off is not optional. It is the price reality pays to remain internally consistent. What makes this especially powerful is that these effects are not just theoretical curiosities. They are built into the technologies we rely on every day. Satellites orbiting Earth experience time differently from clocks on the ground, both because of their speed and because of gravity. If engineers did not account for time dilation, GPS systems would accumulate errors of several kilometers per day. Particle accelerators routinely observe particles living longer than they should, simply because they are moving close to the speed of light. These are not edge cases, they are direct confirmations that time and space truly do adjust themselves. The deeper lesson is that the universe does not bend light to fit our ideas of time and space. It bends time and space to fit light. Light speed is the anchor point, the fixed reference around which everything else is arranged. As objects move faster, they are forced to borrow more from space and less from time, or vice versa, but the total always respects the same limit. This is not a failure of common sense. It is a reminder that common sense evolved for slow, moving creatures on a small planet, not for understanding the fundamental structure of reality. When we accept that time can slow and space can shrink, we are not abandoning reason. We are following it to its logical conclusion, guided by one simple, stubborn fact: the speed of light never changes. When people hear that nothing with mass can reach the speed of light, it is tempting to imagine this as a practical problem rather than a fundamental one, as if we simply haven't built a powerful enough engine yet. But the true reason is far deeper and far more absolute. As an object accelerates and its speed increases, the amount of energy required to keep accelerating it does not increase in a simple, linear way. Instead, the closer the object gets to the speed of light, the more stubborn it becomes to further acceleration. Each tiny increase in speed demands disproportionately more energy than the last. This is not because the object is getting heavier in a classical sense, but because energy and momentum behave differently when space and time are linked by a universal speed limit. The equations that describe motion in such a universe are not forgiving. They do not allow shortcuts or clever tricks. They point toward a hard boundary that cannot be crossed. The key idea is that energy and speed are no longer related in the simple way we learn in everyday physics. At low speeds, adding energy increases speed in a straightforward manner, which matches our intuition from pushing objects around or driving cars faster. But as speeds approach that of light, the relationship bends dramatically. The object's total energy continues to rise, but its speed increases by smaller and smaller amounts. To push the object all the way to the speed of light would require an infinite amount of energy. Infinite does not mean very large. It means unachievable in principle. No matter how advanced a civilization becomes, no matter how clever its technology, it cannot supply infinite energy. This is nature's unmistakable signal that the speed of light is not merely difficult to reach, it is unreachable. What makes this limit so powerful is that it applies to everything with mass, without exception. Electrons, protons, atoms, spaceships, and even hypothetical materials all face the same barrier. The universe does not discriminate based on size or composition. The rules are universal. Massless particles, like photons, can move at the speed of light precisely because they have no rest mass and therefore do not face this energy barrier. Massive objects, on the other hand, are locked into always moving slower than light. This sharp distinction is not arbitrary. It falls directly out of the structure of spacetime itself. The presence of mass ties an object more tightly to time, preventing it from converting all its motion into motion through space. Another way to understand this is to think about how motion through spacetime is divided. Everything moves through spacetime at a fixed total rate, but that motion can be split differently between space and time. Objects at rest in space move fully through time. As they gain speed through space, some of that motion is diverted away from time, causing time to slow down for them. Reaching the speed of light would require an object to move entirely through space and not through time at all. For something with mass, this is impossible. Mass anchors an object to the flow of time. No matter how much energy you add, you cannot completely shut off its motion through time. The infinite energy requirement reflects this impossibility in mathematical form. This perspective also reveals why the idea of breaking the light speed limit is fundamentally different from overcoming previous barriers in physics. The sound barrier, for example, was once thought to be insurmountable, but it turned out to be a challenge of engineering, not a law of nature. Sound waves travel through a medium, and their speed depends on the properties of that medium. Change the conditions and the limit changes. Light, however, does not need a medium, and its speed is not negotiable. It is baked into the geometry of spacetime. There is no environment to modify and no material to optimize. The limit does not come from resistance or friction. It comes from the way distances and times are defined. This infinite energy barrier also protects the consistency of cause and effect. If massive objects could reach or exceed the speed of light, they could potentially outrun light signals and disrupt the causal structure of spacetime. Events could influence other events in ways that defy a consistent order. The energy requirement prevents this from happening in the most decisive way possible. By making light speed unreachable for massive objects, the universe ensures that signals influences and causal relationships remain well behaved and logically ordered. What is remarkable is that this conclusion emerges not from philosophical arguments but from careful reasoning backed by experiment. Particle accelerators have pushed particles to within a tiny fraction of the speed of light, and every time the same pattern appears. As more energy is poured in, the particles do not significantly increase their speed. Instead, their energy shows up in other ways, such as increased momentum and relativistic effects. The limit is not theoretical guesswork. It is observed reality. The deeper message behind the infinite energy requirement is that the universe is not built to allow unlimited motion through space. Freedom of movement exists, but it comes with a cost that grows without bound. The speed of light marks the point where that cost becomes infinite. It is a boundary not enforced by walls or forces, but by the very mathematics of spacetime. In this sense, the speed of light is not just a speed. It is a statement about what kinds of motion are possible in our universe and which are forever forbidden. One of the most profound roles played by the speed of light is its protection of cause and effect, the simple but essential idea that causes come before their effects. In everyday life, this ordering feels so obvious that we rarely think about it. You strike a match, and then it lights. You speak, and then someone hears you. This intuitive flow of events depends on information traveling in a consistent and orderly way. The speed of light defines the maximum speed at which any influence signal or information can travel through the universe. By setting this limit, the universe draws a clear boundary around what events can affect each other and in what sequence. Without such a boundary, reality would lose its logical structure, and the distinction between past, present, and future would become dangerously ambiguous. To understand why this matters, consider what would happen if information could travel faster than light. Because space and time are intertwined, different observers moving relative to one another do not always agree on the timing of events. They can disagree about which events are simultaneous and which happen first. Normally, this is not a problem because the speed of light acts as a universal referee. If a signal travels at or below the speed of light, all observers, no matter how they move, will agree on the causal order of events. A cause will always occur before its effect. But if a signal could travel faster than light, this agreement would break down. Some observers would see the effect happening before the cause. The universe would allow contradictions in the very fabric of time. This is not a matter of perception or delayed observation. It is a fundamental conflict. In a universe with faster than light information, it would be possible, at least in principle, to send messages into the past from certain points of view. You could warn someone about an event before it happens, or worse, create situations where an event prevents the cause that was supposed to create it. These so-called causal loops are not just puzzling, they undermine the logical consistency of reality. Physics depends on the assumption that initial conditions lead to outcomes in a well-defined way. If effects could influence their own causes, that assumption would collapse. The speed of light prevents this chaos by dividing space-time into regions of possible influence. For any event, there is a set of events that can affect it, and a set of events that it can affect. These regions are defined by light traveling outward from the event, forming what physicists call a light cone. Anything inside this cone can be causally connected, anything outside cannot. This structure is not imposed by human convention or mathematical convenience. It is a real physical feature of the universe. Every event carries with it a built-in map of what it can and cannot influence, all determined by the speed of light. What is remarkable is that this causal structure is the same for all observers, even though they may disagree about distances, times, and simultaneity. The speed of light ensures that while perspectives differ, causality does not. Everyone agrees on which events can be causes and which can be effects. This shared structure is what allows the laws of physics to work consistently across the universe. Without it, there would be no stable foundation for prediction, explanation, or scientific reasoning. This also reveals why the speed of light is not just a speed but a fundamental organizer of reality. It sets the rhythm at which the universe unfolds. Events are not just scattered randomly in space and time, they are linked by causal chains that respect the light speed limit. This gives the universe a coherent narrative structure, where the present grows out of the past and shapes the future. Remove the limit, and that narrative dissolves into a tangled mess of contradictions. The importance of this limit becomes even clearer when we consider how deeply it is woven into modern physics. The equations that describe particles, fields, and forces all assume a causal structure defined by the speed of light. They are built to ensure that influences propagate in an orderly way. Attempts to imagine faster than light signals almost always run into paradoxes or require such extreme conditions that they end up reinforcing the same conclusion: causality must be protected. The speed of light is the guardian that stands at the gate. On a deeper level, this shows that time is not just a sequence of moments flowing independently of the physical world. Time is structured by what can influence what. The direction of time, the distinction between before and after, gains its meaning from causality. By limiting how fast information can travel, the speed of light gives time its arrow and its coherence. It turns a collection of events into a connected history rather than a chaotic jumble. What makes this idea especially striking is that it emerges from the same simple fact that started the entire discussion: the speed of light is the same for everyone. From that single constraint flows not only time dilation and length contraction, but also the preservation of logical order in the universe. The speed of light is the silent rule that keeps reality from tearing itself apart. It ensures that causes remain causes, effects remain effects, and the universe remains a place where understanding is possible.